Hi, Kerry. Welcome. Kerry McLaven is CEO of the Forest Gene Conservation Association, a not-for-profit organization promoting conservation, restoration, and sustainable use of the genetic base of the forest under climate change. So that's a big role. Prior to that, Kerry was treasurer of this same organization for 4 years. And before that, she found her passion for all things tree seed and program management at Forests Ontario. Kerry has a Master's in Forest Conservation from the University of Toronto and a Bachelor of Science in Environmental Science. Her work history includes working with FP Innovations, Wildfire Research Team in Alberta, Ontario Parks, and tree planting in Northern Ontario. Welcome, Kerry.
Hello and bonjour. I can hear myself speaking, Yvonne. Hopefully now everyone can hear me.
Yes.
Okay, great. Thank you a lot for allowing me to attend virtually today. I really wish I was there in person. It seems like there's very interesting discussion. So you all know my name, Kerry McLaven. I'm happy to be here representing the Forest Gene Conservation Association. I'll use FGCA for short. I'm grateful to be here to share what we have learned through our implementation of assisted migration trials in Ontario. We are not an organization of scientists. We pride ourselves in helping to translate the research, the incredible research that's going on, into practical applications for people that want to take action on climate change and partners and collaborators that have the ability to do this on site. So quickly, I'll talk a little bit overall about our organization. We want to make sure that genetic diversity is recognized and protected as the foundation of a resilient forest. And that's our current ecosystem as well as what we might be facing in the future. Our main program areas include species conservation. We work with species at risk like butternut and black ash now in Ontario, recovery of those species, and understand other trees that might be in trouble, hemlock, and other beech species like that. We have a seed management expertise program where we are managing white pine seed orchards in Ontario, doing cone collection. We develop really cool publications, cheap promotion here of our certified seed collector manual. Our climate change adaptation work, which we'll talk a little bit about today, assisted migration trials and helping practitioners build climate-ready projects. And of course, education and advocacy on all of these matters. So when we think of assisted migration, we always sort of put it in the pile of climate change, but it's important to think about it from all of these elements of our program for species that might be at risk due to climate change or that aren't able to move because of fragmentation of our landscape. This might be part of species conservation. Also, seed management. Whatever we move will contribute to the genetics of our future forests, so we need to be conscious of that and how seed will eventually be produced and how that will impact the health of our forests. So again, we're not scientific researchers. We like to consider ourselves translators, keeping up with the current science and bringing it to practitioners in a way that applies to them. And I say practitioners, but also mean landowners. We work with landowners as well in Ontario. This work is meant to guide changes, but we do not produce a one-size-fits-all approach. It does depend on the landscape, the sites, as well as the experience of the local practitioners that we're working with. Also remembering, and I know there's a great discussion before, as modern climate science is not a guarantee, it is a prediction, and our environment is an incredibly complex system. We don't fully understand it, but we do need to take some action because we have affected the landscape. So today, just talk a little bit about the background for our work, how we got to where we are, talk about the locations and partnerships that we developed in assisted migration trials, some details on implementation, lessons learned, a tip of the iceberg on lessons learned, and what's next in terms of our trials. So it was important when we started this work that we considered not only the short-term objectives of monitoring how these trees perform, but also the long-term objectives of these tree species that have a lifetime of potentially 80 years. We can't just think about now how they're performing, we need to consider how they'll perform on site in the future. The other thing is considering future climate changes and the site and how it could affect the overall performance of the species we selected. So before we even consider designing a project, we need to consider all of these elements. Obviously the climatic changes, which is what we're talking about today. But then also, I think part of the discussion today was the current species suitability. What's suitable for that site right now? Karine, I think, discussed a lot of that today. And then what is the future species suitability for that site? The other part we need to consider is the site conditions that we're planting on. You can't necessarily bring some of the other species the other speaker was talking about in if the site is not suitable for that species, and we have to consider that. And of course, being a genetic association, we go back to our roots. How are genetics going to play a role in all of this? We're not talking about diversity at the species level, we're talking about diversity at the genetic level. And last but certainly not least, is the foundation to any forest, the seed. Small but mighty packages of genetic information that will determine our future and set the course for our future forests. And these trials will contribute to the gene pool of our local forests, so it's important to consider. Now, Patricia discussed this in great detail, and I just again, for our context and when we develop these, understanding that natural migration rates are 10 to 50 kilometers per century. And the way we have changed the climate, we're expecting the shift up to 700 kilometers. And when you put that on a map, it's pretty significant. Not only that, we have very fragmented forests, I'm sure in areas of Quebec as well as Southern Ontario. And so these tree species are not going to be able to do this on their own. They've never experienced something like this before, so it's safe to say they may need a little bit of help. I'm not going to go into this in any detail again because Patricia and Karine both discussed this. But just to understand where our organization is working, we work within the lower risk, the assisted population migration, working with species that are widely distributed, but working with them within their natural population and natural range. So this is considered low risk. And when we are working in these trials, and with our partners, we are often encouraging people to do things at this level. So I love these images, and I think it's sort of building on what Karine was talking about. But it just shows you these are all the processes that a tree has to undergo within a growing season. And so in a shorter growing season where we are right now, the tree has to undergo all these things: dehardening, root growth, bud break, shoot elongation, all these sort of things, and be finished with that by the time the growing season ends. So this is a short growing season. So what happens as the climate changes and the growing season increases? The trees that we have right now are programmed in a climate that we're experiencing right now. So they're not necessarily going to be able to take full advantage of that new growing season. We know that there is some plasticity between species, but that will only carry them so far. So this is a longer growing season. A species that may be farther south, let's say, of the same, that may be able to take advantage of this longer time period and have different processes along that timeline. So let's look at an example scenario. We have our current forest here in red, adapted to a shorter growing season. We know the growing season will increase while the current forests are unlikely to change enough to account for this increase. So we may bring in some tree seed, yellow here, from a climate closer to the future predicted climate. And then maybe another source, green, again, perhaps from another, and allow these sources to mingle to maybe create that diversity and create that resilience that we're looking for. So again, similar to what Patricia was discussing earlier, but this was our practical way of understanding sort of a very complex process that would be undergoing. And much as Karine was discussing, not only do we need to consider sourcing from a southern climate, we also have to look at the reality of where we are sourcing that material from. Assisted migration trials are fantastic tools to understand how trees will perform when they're moved. However, the trials could also be the future seed production areas, as I said, because we are working in a landscape that is so heavily fragmented. And as an organization sourcing seed for a number of projects, we cannot expect just to look south, even to our US counterparts, and expect there to be healthy stands of trees and individuals readily available to supply seed. So talking about the actions, this is a site that really started it all for us. This site is a Canadian Forest Service research site. It's in Claremont, Ontario, just east of Toronto. It's a 40-hectare site, now part of the Rouge National Urban Park in Ontario. There are a long list of trials on the site. It's a pretty impressive project. There's conifer-assisted migration trials, as well as assisted migration trials of hardwood species. So this is the spot right here where the hardwood species were planted, and actually just visited only a couple of weeks ago, and the trees are growing beautifully, and there are some outcomes of that. So on that site particularly, 6 hardwood species were selected: black walnut, shagbark hickory, white oak, black oak, red oak, and sugar maple. And those species had 4 different seed sources: Ontario, Pennsylvania, US, Kentucky, and Tennessee. So in terms of results, height and survival measurements were taken at 10 years after planting. The local stock performed well, but so did the stock from Pennsylvania and even the stock from Tennessee. Most species performed well at or beyond northern range limit. Hickory was actually a poor performer and not necessarily related to climate, more to do with the challenges and how sensitive the species is to transport and planting. But it's incredible to come back and visit this site and see the growth. There actually is a publication completed, accepted in 2023 that will be out on this site, and again, happy to share that when it comes out. But this site was definitely the inspiration for a lot of our work. As we, the FGC, are not a landowner, it was imperative that we find partners that would make excellent long-term hosts. So we needed local partners of these sites, we needed long-term ownership, and a vision. So just to give you a perspective about where these are, and I did put a little bullet here where you're all sitting today in relation to our projects. So we have 6 sites, 1, 2, 3, 4, 5, 6 across Ontario. This is the Claremont site I was describing before. On these 6 sites, we planted a local source along with 2 or 3 southern sources. The idea was to monitor them for growth, health, and manage them eventually as a seed production area, using these seed sources for local plantings. Plantations were all approximately 2.5 acres in size and included buffer plantings around to protect them from windbreak protection. The trials and their establishment dates are here. We have the first one was planted the same year as the Natural Resources Canada site with a private landowner. And you can see for the next couple of years, we planted the other sites. And you can see we have various partners. We had private landowners, municipalities, conservation authorities as partners, hosts. So in terms of implementation, we had to consider the short and long-term objectives, site soil conditions, texture and drainage, site similarity to the local forests. We wanted to make sure the sites were comparable to ones that we were planting the species in. Exposure and sunlight, competing vegetation was a big one, and animal predation, which I believe was also discussed earlier by Patricia. Before we started in on the project, we had to consider a lot of factors, making sure that we selected the right species for the site. And we had to ensure that the design of the plots were random. There was procuring the site, planting the site, and we needed a lot of support from our partners, volunteers, staff resources, site preparation and tending work, browse protection and fencing. And really, I think the biggest one is the seed and stock sourcing and transportation that is often overlooked and is a big part that needs to be planned in advance. In terms of the climate similarity work, I'm just going to tell you the example of this Kingston Baroque site. So this is where the planting site was. We used a tool called Seedware to generate a map for each site to show us, climate similarity as compared to where we were looking to source those trees from. So we ended up planting from these various areas. The tool Seedware actually was designed by the Canadian Forest Service out of the Great Lakes Forestry Center in Sault Ste. Marie. It's used in Ontario by us as well as the government and other organizations. So in terms of the sources, so our local source from Kingston we had a Southwestern Ontario source, which was 10-degree growing days longer than our local. Pennsylvania, which was 20-degree growing days longer, and Tennessee, which was 40 degrees days growing. Just in terms of design of the layout, this is our first project that we did, and this was the final one. So something that we learned along the way is consistency here is pretty important. But again, we're not scientists. We were doing the best with what we had. But we wanted to make sure there was even spacing. The plots originally included 36 trees at 6x6 spacing, and after thinning, we were hoping at the end to get 9 trees in each plot as sort of the final site conditions. We also needed to make sure they were planted in rows so that we could manage the competing vegetation. And I wanted to show this one just because this was the one that in closest proximity to today's workshop. This site is about 2.5 hours away from the workshop site today. It was a red oak and Baroque trial, and it contained sources from Tennessee, Pennsylvania, local, and as well as some Southern Ontario sources. Johan, I'm wondering if we can just show this video quickly that I sent you. I'm not sure if I can play it from here, but
I thought, what a forward-thinking idea to be a part of something like this, future seed source, and to see how assisted migration could work over a number of decades.
As many people have heard, one of the best ways to combat climate change is by planting trees, and to plant trees, we need seed, and climate-ready seed. So as the climate is changing, that's where a site like this, having a diversity of sources, local and some southern sites, we're hoping to have seed that is going to be reasonably adapted to our future climate. But here today, we've gone through and we've already pre-marked a number of trees for thinning in this plot. Strategically hoping for relatively even spacing. We're looking to get down each plot from the 3 different sources has 36 trees. Eventually we're hoping to get down to 9 in each plot that repeats throughout the site. And so we've strategically selected specific trees to remove for spacing. The health of the tree, we've kind of selected hopefully the best trees for future seed production.
Sometimes a decision is the right one to make, and it's going to be a long time involved. But if you didn't make this decision, you didn't get the reward later on of looking back and seeing the end result. And I can picture this. Quite a number of big seed trees producing regularly, especially with oak trees living so long. So that's kind of my vision, and I think it ties in well with what the founders of this project have in mind as well.
So that was a landowner. That was the first site that we worked on, and that was a landowner, Phil Holst. He was the landowner, and he was really passionate about this. A woodlot owner himself in Ontario. I know it's really hard to visualize these plots, so I want to give you a bit of what that looked like by walking through it in a forest. Fortunately, our partners, Upper Thames River Conservation Authority, filmed that and documented it. In that video specifically, we were doing our first thinning of the site, so it was pretty exciting for us. So moving on, and just in terms of monitoring, we did work with the University of Guelph to do measurements specifically of that site in November of 2018. And then this past winter, 2022, we completed measurements of tree height and tree DBH on all of the assisted migration sites. And we're doing this with the support of the Canadian Forest Service in Sault Ste. Marie. And right now the final results are being compiled by our partners there. And we are hopefully going to be having a report on that, which I would be happy to send to the organizing committee here. But general observations, most trees were doing very well, especially where competing vegetation and natural recruited trees were managed. We definitely saw some frost damage, and I'll talk about that in a little bit, but for the most part, they healed well. Seed observations, it actually seems rare that seed would develop so early, and especially in the bur oak, but we have actually collected seed in the bur oak in 2023. We will be doing germination testing and at the nursery, and the results will be documented. You can see on the right here, these Tennessee acorns were significantly larger than our local acorns. And we've seen this with other projects as well. So it could be, a genetic, the nature of that population in that area, because they have more time to develop their seed and have more resources to do that. We are telling our partners that they should likely use these seeds on sites that are similar to this growing site so that they can yield similar performance. Frost damage was definitely one that affected a lot of the Tennessee source. It seemed to be the worst off in terms of damage. A lot of major wounds you can see here, specifically sun scald and frost cracking. And that would just be because the contraction of water and like I showed you, the dehardening process would have started, but here in Ontario, we could get a frost in late March or early April even, and that would have caused that frost damage when that tree was more susceptible to that. So, and this can happen, but you can see here, there's callousing happening. So the tree is somewhat responding positively to the healing. And as with every operational study, we're not immune to insects and diseases here that affect these tree species. Unfortunately, this little guy here, rose chafer, absolutely destroyed our site in Barrie, Ontario, eating all the fine roots of every piece of vegetation on site. Was terrible. Oak scale here is a common pest. It can cause stunting and dieback, which would be challenging to our trial. And oak gall causing swelling of branches, affecting leaf growth. Spongy moth or gypsy moth was also a major factor in 2022, and we needed to manage that on some of these sites so we didn't lose the trees entirely. So there was quite a few lessons learned, and this is sort of the tip of the iceberg, but one thing that is absolutely critical when undergoing this work is species identification. When we're sourcing in areas where we're not able to collect the seed, we rely on partners and seed suppliers giving us information and material that is source identified. And there's actually a few species in our trials that slipped through the cracks. We ended up receiving blackjack oak, which was actually supposed to be white oak on one of the trials, and that was misidentification. And we didn't really detect that until later on when the plantation was a bit larger. So that was assisted range expansion of that species, so not ideal as part of this project. So ensuring species ID of the stock is very important. So on the other part is sourcing seed is a better tactic than sourcing stock. Moving stock over borders is an incredible challenge. Moving seed is also a challenge, but moving stock is even more so. Planting plans should be adequately marked and colored because of the longevity of these sites. We need to make sure that we can go back to them and measure the plots and ensure we're identifying those sources. Ensuring plot design consistency. So making sure that all of the trials have a similar plot design so that we can monitor how the various plots are performing based on the site differences. And then including a monitoring manual for our partners. We cannot necessarily get out and monitor these on a regular basis, so making sure our partners have, our landowners have ways in which they can monitor it themselves and observe the differences. Documenting microsite differences, so drainage and that sort of thing, drought conditions that affect on sites is really important to see how the species are performing under those conditions. And finally, not least at all, is long-term funding, because these projects, although they're great to install and they do involve quite a bit of funding to do so, they do also require a lot of funding to maintain them over the long term. So that's an important consideration. Oops. So overall process to consider in this, in terms of climatic sources, you need to know if you're going to do a trial, progeny test. Is it just an observational planting or demonstration planting for partners and landowners? Or is it a seed production area? Knowing your objectives far ahead is very important when designing these things. Site security from herbivory is very important. These species can live up to 70, 80 years old. Also, we have found that when you bring material in from somewhere else, the deer are so pleased with us, and it's a buffet for them. So deer fencing and exclusion areas are very important. Making sure we're using the correct tools, but also the tools in combination with the site types and characteristics is very important. Sourcing seed, I think, is the biggest one. Ensuring the right species for the right site first and foremost. Then knowing for sure the source of the seed that you're getting for the site, and ensuring that seed is maintained as quality. It can reduce quality when being transported long distances. So it's an important piece to make sure you are understanding what seed quality is and how it should be maintained. And then planting and ongoing maintenance, I said, adequate resources, predominantly funding to support the planting and long-term management. So where do we go from here? The trials have been very valuable for us from a learning perspective, and also for our partners for understanding how far they can move things safely and the considerations that they need to make. So the original objective, from the original objective to trial design, management, and now seed collection, the purpose has really evolved of these trials, but their value has certainly not changed. They're incredibly valuable that we established them now, 12 years ago. We're definitely reaping the rewards of that. And we continue to use these sites as an example of how important it is for us to diversify our seed sources and how important seed quality is for restoration work. And especially in areas where we have fragmented forests, where these forests are unable to make these moves themselves. So I am thankful for the organizing committee for reaching out, allowing me to share this with you today. I'm happy to connect with anybody that has, I know we have questions after about our work or our methods. We also have lots of ways you connect with us online or social networks, and we're happy to help or even collaborate on any of these types of projects. So thank you very much.
Thank you. Thank you, Kerry. Donc, Alison, si tu peux venir me rejoindre. S'il y a des questions, vous pouvez les poser en français. Alison va les traduire. Autant pour Karine que pour Kerry. Donc, est-ce qu'on a des questions?
Oui, j'en ai une, mais pour la foule, est-ce qu'on a une expérience, semblable à celle qui vit en Ontario, au Québec, aussi avancée que celle-là?
Nathalie, est-ce qu'on a quelque chose? Ah, OK, oui. Vas-y, Julie.
Est-ce qu'on Oui, là, on m'entend. En fait, nous, au ministère, on a installé des tests. Donc oui, on a des dispositifs de ce genre-là, notamment sur le chêne rouge sur lequel on travaille actuellement. On a différents sites sur lesquels on a planté différentes provenances qui viennent d'un peu partout. Nous, au départ, l'objectif, c'était pas de faire de la migration assistée, c'était de faire de l'amélioration génétique. Donc, de voir la variation de la croissance au sein de l'espèce. Puis après ça, d'aller sélectionner les arbres les plus productifs. Mais là, ces dispositifs-là, ces tests de provenance-là, ça, c'est un test de provenance-descendance. Donc, on a l'information sur l'origine, mais aussi la famille, nous permettent là, de faire des inférences là, en termes de migration assistée, puis c'est sur quoi on travaille actuellement. Puis nous, dans ce dispositif-là, on a 3 sites, même, il y a des sites qui sont dédoublés, mais notre objectif, c'était vraiment de caractériser de façon très fine l'effet de la provenance. Donc, nous, on a beaucoup de provenances. Là. On a peut-être une trentaine là, de provenances de l'Ontario, du Québec, puis du nord-est des États-Unis.
Donc, ça, c'est le chêne rouge.
C'est le chêne rouge. Puis nous, ça a été planté, si je me rappelle bien, en 92. Donc, nous, nos chênes commencent à faire des semences aussi. Puis moi, je suis bien curieuse de savoir qu'est-ce qui va arriver avec ça.
Pour d'autres espèces, il n'y a pas d'autres essences où il y a des
Bien, on a différents tests. C'est beaucoup le fédéral, là, que je pointe Nathalie, là, qui a installé des tests de provenance, surtout pour la grande majorité des espèces là, à vocation économique. On en a nous autres aussi, l'épinette noire, le pin blanc. Le pin blanc a des beaux tests de provenance. L'épinette blanche, certainement, notre espèce emblématique. En tout cas, pas emblématique, mais on aime beaucoup. Vedette. Peu de feuillus pour l'instant. On aimerait peut-être en avoir un peu plus. Il y a eu des tests qui ont été faits aussi là, à plus petite échelle, là, différentes espèces qui ont été plantées dans nos arboretums, puis on fait un exercice actuellement avec Catherine là, pour faire un peu un bilan de ce qui a été fait dans le passé, qu'est-ce qui a marché, qu'est-ce qui n'a pas marché, qu'est-ce qui n'a pas marché. Moins de provenance, mais oui, ça se fait. Les tests de chêne rouge, il y en a un qui est proche de Québec, donc à Saint-Anselme. Il y en a un en Estrie, God-Manchester. Ah non, God-Manchester, c'est pas en Estrie. Je ne sais pas si c'est où, lui. Puis il y en a un à côté de l'aéroport de Sherbrooke. Ils sont très beaux.
Et puis François Hébert de la direction de la recherche forestière, on est aussi en train de starter un projet avec le CERFO de migration assistée de chêne rouge. Ça va être au Bas-Saint-Laurent, en Gaspésie. Donc, on devrait installer ça en 2025. Donc, on va utiliser là, différents niveaux d'ouverture. C'est après coupe partielle. Donc, on va utiliser différents niveaux d'ouverture de coupe. Donc, on va installer ça en 2025.